Hello everyone. We'll wait for some 5 minutes to for everyone to join, and then we'll start the session. Hello everyone. I hope I'm audible. Can someone confirm?
Yes, ma'am, you're audible.
Yes, ma'am, audible. Evening, ma'am.
Good evening. Good evening
Good
everyone.
evening, ma'am.
So, welcome to week 8 TA session for drug delivery principles in engineering. And I'll now share my screen. Let me know if you guys can see the screen. Is it visible to everyone?
Yeah, ma'am. Able to see.
Okay. Okay, so we'll start the session. So here are the topics that were covered in the previous week. The route-specific delivery, transdermal, inhalation, buccal, rectal, intra-articular, intravenous administration, wherein approved nanocarriers and immune system was also discussed. So here is the first question. Before we start, this entire session is recorded and this entire session will be uploaded on YouTube. Also, this presentation that I'm discussing today will be shared over Google Drive, and the link will be shared with you guys. Okay, so here is the first question. What is the ideal size range of the nanoparticles such that it can traverse through the smallest capillaries inside the body and not get cleared by the renal system? Options are 10 nanometer to 5 micron, 1 to 1000 nanometer, 1 to 10 micron, 1 to 10, 1 micron to 10 micron. Okay, I think the same option is repeated. 100 nanometer to 2 micron, 1 centimeter to 2 centimeter, 1 mm to 2 mm, 1 nanometer to 100 nanometer.
Option 1.
Option 1, okay.
Option 1.
10 nanometer to 5 micron, okay. Others? Anyone else would like to answer this question? Ideal size range of nanoparticles?
Ma'am, one only, ma'am. I guess it is one only.
Okay. Anyone else? Yes, you're correct. It's first option, 10 nanometer to 5 micron. So particles about 10 nanometer can't be excreted by kidney, and so you can consider from 10 nanometer to 5 micron can easily traverse through the blood vessels and not get cleared by the kidney system. The next question, which of the following is an ionic liquid? Acetylcholine, choline and zeranate, 0.9% saline solution, borosilicate glass, phosphate buffered saline.
Option 3.
Option 3, okay, 0.9% saline solution. Anyone else?
Option 2.
Option 2, okay,
Option second, ma'am.
okay. Anyone else? Which of the following is an ionic liquid? Okay, it is in fact choline and zeranate. Choline and zeranate is the correct answer. If you have gone through the lectures, they have discussed a paper where it is mentioned that choline and zeranate is an ionic liquid. Okay, let's move on to the next question. So this is the third question. The density of two particles are in a ratio of 1 is to 16. What is the ratio of their aerodynamic diameters given all the other parameters are the same? Options are 1 is to 16, 1 is to 256, 1 is to 4, 1 is to 2.
1:4, ma'am.
1 is to 4, okay.
Option C.
Option C.
Option 3.
Okay. Anyone else? Anyone else would like to answer this question? Okay, option C is the correct answer, 1:4. So the aerodynamic diameter is given as d aero equals to diameter equivalent rho density to the power 1 by 2 or under root density. So here density was given as density of the two particles was given in the ratio of 1:16. So we'll take a root over this 1:16 ratio, that will give us the aerodynamic diameter ratio of the two, that is 1 by 4. Okay, next question. What size range of particles are well suited for deep lung delivery? The options are 3 millimeter, 4 meter, 1 kilometer, 1 to 5 micron, 100 nanometer, 1 nanometer, 1 angstrom.
Ma'am, option 4, 1 to 5 micron.
Okay.
Option 4, ma'am.
Option 4.
Okay. Anyone else? What size range of particles are well suited for deep lung delivery? Yes, it's 1 to 5 micron. It's directly mentioned in the lectures if you have gone through those. Powder particles should be around 1 to 5 micron for deep lung delivery. Let's move on to the next question. The mechanism of particle deposition into the lungs for large airways, bronchioles, and alveoli in order are. The options are impaction, gravitational sedimentation, and Brownian diffusion. Brownian diffusion, then gravitational sedimentation and impaction. Impaction, Brownian diffusion, and gravitational sedimentation. Gravitational sedimentation, impaction, and Brownian diffusion. Gravitational impaction, Brownian sedimentation and diffusion. Sedimentation, gravitational diffusion, and Brownian impaction. Which of these is the correct order for particle deposition in the lungs?
Option A, ma'am.
Okay. Impaction, gravitational sedimentation, and Brownian diffusion. Okay.
Ma'am, same ma'am.
Okay.
Option A only.
Anyone else would like to answer? Yes. Anyone else? Okay. Option 1 is the correct answer. It's impaction that will lead to deposition near bronchi, bronchioles, and then followed by sedimentation, then Brownian diffusion, lead to final deposition at the alveolar sacs. Okay, let's move on to the next question. Where will particles of size 20 micron mainly deposit after dry powder inhalation? You have to select two answers: nose, mouth and throat, large airways, alveoli, and systemic circulation.
Option B and C.
Option B and C. Okay.
Okay, ma'am.
B and C.
Okay.
B and C only.
Okay. Mouth, throat, and large airways. Anyone else? Where will particles of size 20 micron mainly deposit after dry powder inhalation? Okay, mouth and throat and large airways are the correct options. So here is a plot depicting different particle deposition when given through inhalation of different size range. So for mouth and throat and for airways, it's mostly after 10 micron. So for larger airways, more than above more than 20 micron particles will get deposited in the larger airways and mouth and throat. Okay. Next question. Which of the following statement is false for rectal administration? Options are bypass first pass metabolism, useful for children as it might be difficult to find blood vessels, widely recommended and followed method, drug degradation by bacterial flora, uncomfortable.
C.
Option C, ma'am.
Okay.
Option C.
Okay.
Option C, ma'am.
Okay.
Option 3.
Okay. Okay. You guys are all correct. It's option C, widely recommended and followed method. It is not widely recommended and followed. Rest of the options, that is, it does bypass first pass metabolism, useful for children, and it might be difficult to find blood vessels. And drug degradation happens by bacterial flora when delivered by this method, and it is uncomfortable. So option C, widely recommended and followed method, is the false statement for rectal administration. The next question. Which of these statements are not advantageous for intravenous delivery? You have to select two options: invasive, drug completely bioavailable, rapid response, bypass first pass metabolism, chance of irritation and infection.
First and last option.
Okay,
First and last, ma'am.
okay,
1 and 5.
Same, ma'am. First and last.
okay. Anyone else? Yes, you guys are correct. These are the two options. First option, that is invasive, and last option, chance of irritation and infection, are not advantages of intravenous or IV delivery. Rest of the options are correct. That is, the drug becomes completely bioavailable. It has a rapid response because it is bioavailable, and then it also bypasses first pass metabolism. Ninth question. What are the advantages of using inhalers for drug delivery? You have to select two options: bypass first pass metabolism, manufacturing cost cheaper than oral drug delivery, improved bioavailability as compared to intravenous route, good for delivery to lungs, not very convenient to use.
1 and 4.
Sorry,
1 and 3.
1 and 3. Okay. Anyone else?
I said 1 and 4, ma'am.
Okay.
1 and 4.
Ma'am, 1 and 4, I think.
Okay. Anyone else has any other option as their answer? What are the advantages of using inhalers for drug delivery? Yes, anybody else would like to answer? Advantages of using inhalers for drug delivery? Okay, so here the correct answer is first and fourth options. It bypasses first pass metabolism and it is good for delivery to lungs. Yeah, the third option, that is improved bioavailability as compared to intravenous route, is wrong, because intravenous route has the maximum bioavailability. So delivery by inhalation is basically the inhalation route will have less bioavailability as compared to IV route, and it is not very convenient to use, and manufacturing cost cheaper than oral drug delivery. This might not be true also. So the correct options are bypass first pass metabolism and good for delivery to lungs. Now last question. This is a numerical question. You have to calculate aerodynamic diameter of a polymeric spherical particle with diameter 2 micron and density 4 gram per centimeter cube and shape factor 1. Report answer in micrometers. Calculate aerodynamic diameter of a polymeric spherical particle with diameter 2 micron and density 4 gram per centimeter cube and shape factor 1. You have to report answer in micrometers. What is the aerodynamic diameter?
It may be
4.
4, okay.
2.
2. Anyone else? Anyone else would like to answer? What is the aerodynamic diameter of a polymeric spherical particle with diameter 2 micron and density 4 gram per centimeter cube with shape factor 1? Okay, so 4 is the correct answer. So here, if you see, this is the original equation where aerodynamic diameter is is dependent on the diameter equivalent and under root density by shape factor. Here shape factor is x. Since for spherical particle the shape factor is 1, this becomes negligible. And the final equation will be d aero equal aerodynamic diameter equals to diameter equivalent into under root density. So diameter is 2 micrometer and density is 4 gram per centimeter cube, which is 2 into under root 4 equals to 2 into 2 equals to 4. So 4 micron will be the final answer. Okay. Anybody has any doubt in the questions that we discussed? Yes, I'll repeat once again from beginning for those who joined late. But apart from that, whatever I discussed, if anyone has any doubt now, they can say, or I'll repeat again.
No doubt, ma'am.
Okay.
No doubt. No doubt. Thank you.
Thank you, ma'am.
Thank you, ma'am.
Ma'am, actually, I didn't get any upload of this session. So where can I find it?
Which session?
No, it will be uploaded in the YouTube and link will be sent to us.
Yes, you could not find the link, is it?
Yeah, I didn't find it.
How else is everyone accessing the link? Can someone answer? Or you can post in the forum itself.
Ma'am, we are doing through that link only where there is it has been reported that July recording session. If we click that, then we are able to go to that Excel sheet where all the links are posted for each week.
Right, right.
No, I was asking that. You said no, it will be uploaded in the YouTube. So
Yes,
I didn't
there
find it.
only in
When
the
you click
Excel
the
sheet
links only,
itself.
it will go to YouTube.
Yeah,
Actually,
because we updated in the Excel sheet, so the entire Excel sheet is shared with you people, right?
I'm getting Excel sheet.
Yeah, so there will be different columns: YouTube link, Google Drive link, and the attendance and everything else. So in the YouTube link column, you can see the respective week's link.
Oh, okay, ma'am. I'll check. Thank you.
Okay.
Madam, I need 1 to 4 answers, madam. I have
Yes,
joined
yes,
little bit
yes,
later.
yes. I'll discuss now from starting. Okay.
Okay.
Okay. Okay. So this was the first question. What is the ideal size range of the nanoparticles such that it can traverse through the smallest capillaries inside the body and not get cleared by the renal system? So here the answer would be 10 nanometer to 5 micron. Since kidney it cannot filter particles above 10 nanometer, and so from 10 nanometer to 5 nanometer will be the smallest uh, size range of the nanoparticles that can traverse through the smallest of capillaries of the body. So option will be first option, 10 nanometer to 5 micron. Next question, Which of the following is an ionic liquid? Acetylcholine, choline geraniate, 0.9% saline solution, borosilicate glass, or PBS, phosphate buffered saline. So here, choline and geraniate is the correct option. This is an ionic liquid. Most of these are buffer. Now, third question. The density of two particles are in the ratio of 1:16. What is the ratio of their aerodynamic diameters given all the parameters are the same? So here the correct option would be 1:4, that is option C. So aerodynamic diameter is given by diameter equivalent into density under root density. So to get the aerodynamic diameter ratio, we have to take a root over density ratio, that is under root 1/16. That will give the answer 1:4. The next question was, what size range of particles are well suited for deep lung delivery? So here the answer is straight away 1 to 5 micron. In this size range, you can expect the particles to get deposited in the deep lung. I hope the screen is visible to everyone.
Yes, madam.
Okay. Okay, the fifth question was the mechanism of particle deposition into the lungs for large airways, bronchioles, and alveoli in order are. So the order would be first impaction, then gravitational sedimentation, and Brownian diffusion. So this is how it happens. Due to inertia, it will travel, and then due to gravity, and then Brownian diffusion, it will get deposited. Next, sixth question was, where will particles of size 20 micron mainly deposit after dry powder inhalation? You have to select two options here. So particles particles of size 20 micron would be mostly deposited in mouth and throat and large airways. So this is a plot basically depicting the deposition at different regions based on the particle size. So only 15 micron it's showing here, but if you see up to 15 micron, airways and mouth and throat are the only options where it is deposited. It's already, when it crosses 10, it's already very low for alveolar region. So particle of 20 micron will get deposited in larger airways and mouth and throat. Next question, or the seventh question was, which of the following statement is false for rectal administration? We have to select a false statement. So bypass first pass metabolism, this is the correct option. It is useful for children as it might be difficult to find blood vessels. This is also correct. Widely recommended and followed method. This is not widely recommended, so this is a false statement. So this is the correct answer. Also, drug degradation by bacterial flora, and it is uncomfortable. These are also correct options. So widely recommended and followed method is the correct answer for this question. Now the next question. Which of these statements are not advantageous for intravenous delivery? You have to select two options. Invasive. Yes, the intravenous delivery is invasive, so it is not an advantage. Drug completely bioavailable, this is an advantage. Rapid response, another advantage. It bypasses first pass metabolism, advantage. Chance of irritation and infection, disadvantage. So here not advantages of IV, or basically disadvantages would be invasive and chance of irritation and infection. These two options will be the correct answer. Number ninth question is, what are the advantages of using inhalers for drug delivery? You have to select two options. It bypasses first pass metabolism, correct. Manufacturing cost cheaper than oral drug delivery. This might not be true. Improved bioavailability as compared to intravenous route. Not true. Intravenous route has maximum bioavailability, which is why we consider 100% bioavailability when given through intravenous route. It's good for delivery to lungs. This is an advantage of using inhalers. Not very convenient to use. This is not an advantage. but it is patient compliant. So the advantages of using inhalers would be bypass first pass metabolism and good for delivery to lungs. First and fourth option. Now the last question was, you have to calculate aerodynamic diameter of a polymeric spherical particle with diameter 2 micron and density 4 gram per centimeter cube and shape factor 1. You have to report answers in micrometers. So here shape factor is 1, and it is you can already simplify the equation to aerodynamic diameter equals to diameter equivalent into under root density. And so diameter is given as 2 micron and density is 4 gram per centimeter cube. So we have to take a root over density, that is under root 4. So the aerodynamic diameter would be 2 into 2 equals to 4. So the answer is 4 micron. I hope I discussed all the questions. If you want me to go through any question again, you can say.
Thank you so much.
You're welcome. Anybody has any doubt in all the questions we discussed today?
Thank you, madam.
Yes. Any doubts? Or do you want me to discuss any question again?
Madam, I have one doubt
Yes.
regarding that bioavailability.
Yes.
Madam, in that class, I have read that intra-atrial means in between joints they are injected.
Intra-articular. Intra-articular.
Intra-articular, yes, ma'am.
Yes.
That also having 100% bioavailability, madam? Or,
No, that will also, so intra-articular is basically in the joints.
yes, ma'am.
So from the joints, then it will diffuse and then go to the uh,
Systemic
to
circulation.
bloodstream. Yes. So that will it might be bioavailable if it is mentioned, but then it will also take time. But if you directly inject into the intravenous route, that is directly into the bloodstream, that is faster and that will be
Rapid
100%
response.
bioavailable. Yes. So in intra-articular also, some go to the bloodstream, some are also ejected via the lymphatics, and then they'll get deposited to the intravenous. So it's a long route, so some might not get even there.
Okay. Thank you.
Welcome. Any other doubt?
Okay.
If not, you can leave the session. We can close it now. Question number 2. Okay. Question number 2 was, which of the following is an ionic liquid? So there is not much to discuss here. If you go through the lectures, there they have discussed one paper where it is mentioned that choline and geraniate is an ionic liquid that is used. So it's straight away from the lectures, and that will be the correct option. I hope you got the answer. Okay. Rest, if you see PBS and those are buffers. Point saline solution, those are buffers. You can say this is an ionic liquid. Okay. Any other doubt? Miss Usha Goda, do you have any other doubt? or shall we close the session? Am I audible? Hello?